In this video, we're going to talk about solving one- and two-step equations. The goal is going to be to solve for an unknown variable. In other words, we want to make sure that we isolate the variable to one side of the equation. Before we look at some examples, I wanted to share some tips. So when isolating the variable, think of how to undo specific operations that are happening around that variable. For example, what's the opposite of addition? Or what will undo multiplication? If you are presented a problem where the variable is already isolated, simply refer to your order of operations to help you simplify the other side of the equation. Let's look at one-step equations first. And really what we mean by one-step equations is that it's only going to take one step in order to get the variable completely isolated. Our first problem is 60 is equal to 5 times x. I know that this is multiplication because I do not see any operation happening between 5 and x. So if it helps, or if you need to see it, we could go ahead and put a little dot in between to indicate that multiplication. The only thing that I would really stress to avoid would be to put a multiplication sign in between 5 and x. As you can see, that multiplication sign looks like our variable. So in this situation, it might be difficult to kind of read or keep track of. So again, let's go ahead and just leave the multiplication dot in there if we need it. So the next question that we should ask ourselves is, what will undo a multiplication of 5? Or in other words, what's the opposite of multiplication? So we know that the opposite of multiplication would be division. So I'm going to divide both sides by 5. And again, I want to do both sides because what I do to one side of the equation, I must do to the other in order to maintain its balance. The other reason why we're going to divide, notice that 5 over 5 will reduce itself out, and that's going to leave us with just x. So our final result will be 60 divided by 5 is 12 is equal to x. What we can also do is check to make sure that our solution is correct. This is the nice thing about equations. We do have the opportunity to do that. So we can start off with our original problem. And now I know what x should be equal to, or at least I think I know. So I'm going to go ahead and substitute that in for x. And at this point, we might be able to say, yes, this is a true statement. 60 is equal to 5 times 12. Or we could also go for the very direct route and say 60 is equal to 60. This is what we want to see. We want to see a true statement. So if, for example, you were checking and you got something that said 60 is equal to negative 10, we know that this is an error because 60 is not the same thing as negative 10. If you kind of reframe it with respect to money, if you had $60, someone came up to you and said that's the same thing as being $10 in debt, we would probably kind of furrow our brow or kind of squint at them and kind of say, well, no, that doesn't make any sense. Like, I have money as opposed to being in debt. Let's go ahead and take a look at the next problem. So this one we have 48 is equal to negative 2/3, again, times t, so you can put that multiplication dot in there if you would like. And I intentionally put this problem in because we are working with a fraction in this one as opposed to an integer. So one way that you could approach this, of course, we could undo this multiplication by dividing both sides by a negative 2/3. And what I'm noticing on the left side of the equation is I have a complex fraction. So maybe I want to avoid that. So I'm going to show you a trick. So let me go ahead and start with a fresh problem here. So what I'm going to go ahead and do is I'm going to multiply both sides by the reciprocal of 2/3. So reciprocal just means I'm going to take that fraction, I'm going to flip it over. And what we can kind of note here on the right side is, first off, a negative times a negative would result in a positive value. And then we can also cross-reduce out the 3 and the 2. And if you notice here, the variable t is the only thing that is left. So we can now focus our attention on the left side I'm going to go ahead and write 48 over 1 so that I can clearly see the numerator and denominator of both fractions. So quick tip, if you are given an integer value and you are working with fractions or you want that integer to look like a fraction, simply write a 1 underneath it. So from here, we can go ahead and see if we can cross-reduce. I noticed that 2 would cross-reduce with 48. Both of them have a common factor of 2, so that would leave me with a 1 and a 24. And then we have negative 3 times 24, so this will give me negative 72 is equal to t. And likewise, if you need to double check your work, we could check it. As we can see here, if I substitute negative 72 in for the variable of t, again we would have a negative 2/3 times a negative 72, which would result in a positive result. We can also see that the 3 in the denominator will cross-reduce with the 72 in the numerator, leaving us with 2 times 24, which results in 48. Unsurprisingly, two-step equations mean we are going to need 2 steps in order to solve. Let's dive right in with the first problem. Negative 51 is equal to 7x minus 2. So what I want you to think about is clear out anything that is not directly connected to the variable. So for example, notice that 7 is being directly multiplied with x. So that kind of indicates to you that's probably going to be my last step that I'm going to do. So what I would encourage you to do first would be, well, I can add 2 to both sides relatively easily. It's further removed from the variable, and therefore it's kind of easier to clean out. So by doing that, that negative 2 and that positive 2 will go away. And again, what I do to one side, I must do to the other. So this is what I'm going to add to the left side as well. So this is going to give me negative 49 is equal to 7x. And now we're back to something similar to what we had done with our one-step equations. So again, we have 7 times x. So how do I undo a multiplication? Well, I can go ahead and, instead of multiplying by 7, I will divide by 7. And this will result in negative 7 is equal to x. As you can see from the check below, if you need to, feel free to pause, we do arrive at a true statement. Our next problem is very similar to the one that we just finished. So we have 15 is equal to negative 6/5 times p plus 3. Again, we want to work our way in toward that variable. So the first thing I would suggest doing is focusing your attention on the plus 3, or that addition of 3. So the opposite of addition would be subtraction. So I'm going to subtract a 3 from both sides, again, to make sure that that equation is balanced. This will result in a 12 is equal to negative 6/5 times p. And again, if we need to, we can put that little multiplication sign there. Once again, we want to undo that multiplication of negative 6/5 and p. And if you wish, you can absolutely divide both sides by negative 6/5. That does result in a complex fraction, and we aren't covering that in this video, but you can also use the shortcut that we had discussed in the previous slide, and that would be to multiply both sides by the reciprocal. So the reciprocal of negative 6/5 would be negative 5/6. And I would also encourage you, once you put the negative 5/6 to the left side, write your 12 over 1 so that 1, it looks like a fraction, and 2, you're able to clearly see if you can cross-reduce because you can see the numerator and the denominator of both numbers now. Focusing our attention on the right side first, notice that a negative times a negative would result in a positive. My 6's will cross-reduce, my 5's will cross-reduce, and this will leave me with just the variable p on the right side, which is what I want. Now we can turn our attention to the left side. I do see that 6 and 12 will cross-reduce. They have a common factor of 6. So 6 divided by 6 is 1, 6 divided by 12 is 2. So now we're just left with negative 5 times 2, and this will result in negative 10. Once again, we can check our work. And as we can see, it all checks out. For our final equation, it looks like a lot of the heavy lifting is done. We just have to clean up what we see on the right side, because as we can see, y is already isolated. So to begin, order of operations would say that we check parentheses. Well, there's just a -6 in that set of parentheses, so there's not much that I can do. Next would be exponents. I see no exponents. The next step would be to check for multiplication and or division. So I do see that we have a multiplication going on. I am going to write that -6 over a 1 so I can see if I can cross reduce, and it looks like I can. I see that I have a -6 in the numerator and I have a 4 in the denominator. So both of those are divisible by 2. So my 4 will reduce to a 2. My -6 will reduce to a -3. This is going to result in y is equal to a -3/2 minus 27. If I want to have my answer presented as an improper fraction, then I'm going to go ahead and write 27 to make it look like a fraction, so I'm going to put a 1 underneath it in the denominator position. And then I would actually multiply both the top and the bottom by a 2 so that I now have a common denominator. This is going to give me y is equal to -3/2 minus 54 over 2. And again, if you went to a calculator or you did this by hand, 54 divided by 2 would take you back to 27. So it's the same value, it just has a different exterior look to it. And then from here, we could go ahead and finish this. So we have -3/2 minus 54/2. This would give me -57/2. And maybe you're questioning, would I be able to do this by, say, converting -3/2 to a -1.5 and taking care of the work from there? Absolutely, you can. I would double check with your instructor to make sure that they haven't specified you present the work in a very specific way. Now it's your turn. Go ahead and look at both of these problems. When you're ready, pause the video to work through them. And once you're ready, press play and we will review the solutions. So for our first problem, we have 64 is equal to 4x. This is a one-step equation. We can note that 4 times x, in order to undo that multiplication, we can divide both sides by 4, and then we would see that 64 divided by 4 gives us 16. And then again, you can see the check written below. For the second problem, we have 72 is equal to -27 times x minus 9. Again, we want to work our way in towards that variable, so the easiest step that we can take care of first in this two-step equation is to add 9 to both sides. That would give us 81 is equal to -27 times x. Let's undo that multiplication by using a division. 81 divided by -27 will give us -3, and once again, we have the check below to confirm that our solution is correct.